Have you ever grabbed a wrench and wondered why the head isn't simply lined up perfectly straight with the handle? After all, a straight wrench seems like it should be simpler to make and probably easier to understand. Yet pick up a typical combination wrench and you'll notice something immediately. The working ends are angled or offset from the handle. That little angle isn't decoration, and it isn't an accident. It solves a surprisingly important problem. How do you turn a nut when there's barely enough room to move your hand? Today, we're looking at the clever geometry behind one of the most ordinary tools in your toolbox, and why a seemingly minor bend can make such a huge difference. Right here, on History of Simple Things. Wrenches have been around for centuries in various forms, but the familiar fixed-size wrench developed alongside the widespread use of standardized nuts and bolts during the industrial era. As machines became more complex, mechanics increasingly needed tools that could apply controlled torque to fasteners in increasingly cramped spaces. By the early 20th century, manufacturers were producing specialized box-end, open-end, and combination wrenches in many different shapes. Historical examples show that angled and offset box-end designs were already being produced by the 1930s. The basic problem had already become clear. Machines could put nuts in places where a straight tool simply couldn't swing comfortably. Imagine trying to loosen a bolt with a perfectly straight wrench. You place it over the nut and pull. It works until you discover a wall, another bolt, a pipe, or part of the machine directly behind your hand. A wrench doesn't just need to reach the fastener. The handle also needs space to move through an arc, and that is where the angled head becomes incredibly useful. Instead of keeping the handle directly in line with the nut, the wrench head is tilted away from the handle. That small offset can move your hand away from nearby surfaces and give the wrench a clearer path through its swing. For many common box-end wrenches, the offset is around 15 degrees. It may sound insignificant, but in a crowded engine bay or machinery compartment, those few degrees can mean the difference between getting the job done and repeatedly smacking your knuckles against something. Here's where the design gets especially clever. A standard hexagonal nut has 6 sides. That means the wrench needs to rotate 60 degrees before the geometry of the hexagon repeats itself. But in a cramped space, swinging a wrench through a full 60-degree arc may be impossible. So, manufacturers use an angled open end, commonly around 15 degrees, to make repositioning easier. After turning the fastener as far as the surrounding space allows, you can remove the wrench, flip it over, and put it back onto the nut. Flipping reverses the direction of the 15-degree angle, effectively giving you another position. This allows the wrench to be repositioned in much smaller increments than a completely straight design would allow. In other words, the angle lets you work a nut without needing a huge swing of the handle. That's particularly useful when you're working between brackets, inside engine compartments, around plumbing, or anywhere your wrench has only a tiny amount of room. There's another detail worth noticing. The open end and box end of a combination wrench don't use the angle in exactly the same way. The open end can slide onto a nut from the side, making it useful when you can't access the fastener from directly above. But because it grips fewer surfaces, it generally isn't the first choice when you need maximum grip. The box end surrounds the fastener much more completely. This distributes the force across more surfaces of the nut, allowing the user to apply substantial torque with less tendency for the wrench to slip off. Its offset serves another purpose too. By raising the handle away from the plane of the fastener, it creates clearance for your fingers and knuckles and helps the tool reach over nearby obstacles. So when you look at that angled box end, you're really looking at a solution to 2 problems at once: access and hand clearance. You might assume every wrench has exactly the same angle, but that's not true. 15 degrees is extremely common, but specialized wrench designs can use different offsets depending on their intended application. Some tools are deliberately made with deeper offsets, thinner profiles, or unusual head angles to reach fasteners in particularly restricted areas. That's why professional toolboxes often contain more than one style of wrench. There isn't one perfect angle for every mechanical situation. Sometimes you need the standard combination wrench, sometimes you need a deeply offset box wrench, and sometimes the only practical solution is a ratcheting wrench or socket. Why not just make everything straight? A straight wrench would actually work perfectly well if every nut were sitting in a completely open area. But real machines aren't designed around making your wrench happy. Engines are packed with components. Industrial equipment has pipes, brackets, shafts, housings, and electrical connections competing for space. Even something as simple as a bolt mounted close to a flat panel can make a straight wrench awkward to use. The angled head essentially changes the geometry of the tool without changing the basic way it turns the fastener. You're still applying torque through a handle. The difference is that the handle is positioned somewhere your hand can actually use it. So why do wrenches have angled heads? Because a perfectly straight wrench would often be far too difficult to use in the real world. The angle provides clearance, gives your hand more room, helps the tool work around obstacles, and, especially with the common 15-degree open-end design, allows the wrench to be flipped and repositioned in tight spaces. It's a wonderful example of simple mechanical design. There are no motors, electronics, or complicated mechanisms involved, just a carefully chosen angle that works with the geometry of a hexagonal nut. And the next time you reach for a wrench, that little bend in the head might not look so insignificant anymore. It's a tiny piece of engineering that makes an everyday tool dramatically more useful. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.